I'm using a process here that was established by Cisco. I think this is 2004, 2005. They called it the Cisco series. IEC also uses this procedure. Their standard soils, the IEC standard soils, are test dust, and they use a vegetable oil. I'm just using olive oil today. The important thing is that the organic oils are common, so that if somebody wanted to duplicate this test, they could use a Bertolli olive oil. The test dust is hard to come by; it's expensive. But anyway, the point of this is that these are standard procedures, and if I were a trainer, if I were a researcher in an RBOC, CATV, I'd want to use a standard process, one for training, also to evaluate. I had a jumper labeled at A and B. It was surprising when I booted this up through the ODM. These were already dirty. I do not know how long they had been soiled, but I'll be honest with you, I had a problem cleaning them. And I think this is an important lesson for the data center, for the central office, or where a jumper has been in service for a while. If the thing is dirty, it may take more than once or twice, 3 or 4 times to clean it. I've always been a proponent of first-time cleaning. This is an important year. 2025 is an important year. The standard cleaner, the one that Sticklers was using, for example, is based on the 3M Novec product. That product is coming off the market. There is still a DuPont HFC, and then Honeywell has the HFO. But all three of these, the 3M, the DuPont, and the Honeywell solvents, were just carrier solvents. They had to have a kicker. And the kicker that's in them is called trans. It is not plastic safe. It is used in minimal quantities, and that's what makes these really ineffective cleaners. That is why the precision hydrocarbon works so much better. The precision hydrocarbon is used in minimal quantities, as you see in the lower left, and it does a pretty good job. I was able to clean these really soiled, baked on, if you will, debris, and come up with good test jumpers. So here we are. We have the A jumper and the B jumper. I started off with the olive oil. That's what you're seeing in the upper right. I was really surprised. I only tapped that jumper in a small amount of the olive oil, and it badly oversaturated. There is a problem here aligning the 1.25 thread in the 2.5 millimeter alignment sleeve. And I'm going to document that in a video here shortly. What is critical is that the 1.25 tool, SG tool, will not fit the 2.5 millimeter ferrule. And what that means is that all jumpers using this tool will have to be cleaned in the alignment sleeve. That might be a game ender. This is cumbersome. It's not that it can't be done, but it would really have to be trained. The way I see this is that in order to use the 1.25 ferrule mate, you've got to pull back the sleeve and reveal the cleaning tip. The cleaning tip is in the yellow circle. You then insert the cleaning tip into the alignment sleeve. That assures that that thread is touching the SC ferrule. Now the good news is that thread is on a rather flexible tip. So as you advance it, and I'm advancing this 3 times, sometimes 4 times, that tip is in effect folding over So you're getting what I called yesterday, you're getting a wobble. So you're getting a larger cleaning surface. You're going to see how this works in the videos that are coming up. This is an interesting video. As I moistened the interface, put it into the ODM, the solvent, as you will see, moved across the end face and actually outside of the field of view, even on this scope, which is I think 130x. So in essence, that end face would have passed IEC standards. But as you see in the images below, center, that is a completely clean horizontal end face. I call zone 4, but the rest of the ferrule is contaminated. And then in the bottom right, you can see how that is perspiration and how it extends beyond the core over the total horizontal end face. It's important that we understand there's more to the end face than we've been taught. All right, to make this work, you're going to have to pull back so that the white tip is shown, and then you insert the white tip into the alignment sleeve. Let's see what we get here. I'm doing these 3 times, 2, 3. This is real time. It doesn't really touch it. But you know, this is a really heavy debris also, so you know it's a heavy debris, and the threads are just a very, very small cleaning surface. I mean, you know, if I were perspiring and touched it, that fingerprint could look like that. Let's just see. 4. I mean, it's not really touching it. Okay, so we go ahead and do this. Using what you know as combination cleaning, I call a solvent transfer. And we're just going to go like this. Let's see if there's any difference. Okay, we're much better. That olive oil is surprisingly difficult to remove, but we do get it, okay? All right, signing off. Okay, I am calling this clean on this SC. What we're going to do is what the way Cisco and IEC said, just tap it in there. Okay, there's your dust. I hope you can see that. I really do. Let's see. Okay, there it is. All right, so especially for the dust, we're going to do the solvent transfer, and what that means is we're going to take this tip, hold it in the solvent like that. It's not going to be that difficult when you're in the field. It's just setting it up for the test. Put it back in the alignment sleeve. Pull the little shield back so the tape is definitely going in there. And then we're going to do 1, 2, 3. I don't know. You know, those darn threads, they are just not all that good. Although, let me take a good look. Oddly, that probably passes the current IEC standard, even though there is dust here, 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 and here. If that were high enough, that would create or could create a standoff and a misalignment. But the core is clean, and that's all that matters per IEC under the current standard. For my standard, this fails. Okay, let's try it again. Once again, what I want to do is I always want to moisten these tools, especially when it's coming to a dry debris, because static field, you can generate static field. So again, what I'm doing is I'm pulling the nose back, lightly touching the tape thread as it is in the solvent. Alignment sleeve. Well, that's going to be a pain in the tail. 1, 2, 3. Now, that is through the adapter. We really didn't move it, did we? Okay. So, let's go back to the baseline cleaning, which is the cube. We always want to moisten it. 1, 2, 3. And we're pristine. I don't know if you can see that. I hope you can see that. But that's nice and pristine. So it can be cleaned. It's just that the darn thread is, it's polyester. And it's so very small, it's just difficult to clean. It is what it is. The tape, well, do you have time? Okay, the purpose of this one is going to be to see if